Hello, welcome back to Exploding Chemistry by teacher Susan. Now I would like to share with you the second example on the heat change calculation involving Haber process. Stay tuned. Our second example is formation of ammonia gas through the Haber process. The ingredient or the reactants that we are using here is nitrogen gas and hydrogen gas. Before we can start calculating for the heat enthalpy, we are going to draw out all the structural formula for our reactants as well as our products. The first reactant that involved is ammonia gas, which in return it will become nitrogen triple bond nitrogen. And for hydrogen gas, each of the hydrogen gas is H single bond H, and we have 3 mole. Coming up next, it will be ammonia. Ammonia contains 3 NH single covalent bond. When we have 2 mole, it means we have 6 NH single covalent bond. After we have identified all the covalent bond involved in the structural formula for both reactants and product, step number 2, we are going to identify the bond energy for each of these covalent bond from the bond energy chart that provided just now. Starting up from nitrogen gas, each of the nitrogen gas will contain 941 kilojoule of energy. And for each of the hydrogen single bond hydrogen, we involve 436 kilojoule of energy. And lastly, for the nitrogen hydrogen single bond, each of them is 391 kilojoule of energy. Step number 3, we are going to calculate the total energy needed to be absorbed in order to break the chemical bond. How much energy do we need to be absorbed to break the chemical bond? So we are taking 941 plus the total of 436 times 3, which means we need to absorb an amount of 2249 kilojoule of energy in order to break all the chemical bonds in the reactants. Next step, we are going to look into how much energy that we need in order to form back the chemical bond in the ammonia. In order to form back the chemical bond in ammonia, we need to form 6 nitrogen hydrogen single bond, and the total amount of the energy that they will release during the formation of the chemical bond will be 2346 kilojoule of energy. Last step is the calculation for the heat enthalpy. What are we going to do? We will take the total amount of energy to break the bond minus the total amount of energy needed. Minus the total amount of energy that released during the formation of chemical bond. And we will get a final amount of negative 97 kilojoule of energy. From the final value that we can see here, it carries a symbol negative. When the final value carry a symbol negative, it means that this formation of ammonia gas through the Haber process basically is an exothermic reaction because heat is released to the environment. Right? Hey guys, this is the end of my sharing on the heat change based on the Haber process. kindly like my video, subscribe and hit the button for more video to come. By then, see you!